Assalamu alaikum dear students. In this video we'll see some more concepts and definition on sets. If you want to see our first two videos on introduction of sets, you can just click the I button at the top. Now we'll get into the topic. Right. In last class we saw we start with the concept of subsets. What is a subset? Now we'll see a concept called as an interval. What is an interval? Right. So subsets of real numbers. Subsets of real numbers. We have many subsets for real numbers. Even the natural number is a subset of real number. The integer is also a subset of real number. Whole number is also a subset of real number. Okay, right? Rational numbers is also a subset of real number system. Right? Now, in that, let me take a subset where, but the difference between all these things is in natural number is a subset of real numbers, but we just skip some elements. From 1 we directly jump into 2. From 2 we directly jump into 3. From 3 we jump on to 4, right? So we miss out some elements, right? Now what we are going to see is we are just going to take some subsets continuously. For example, from the entire real number, you know how to draw a real line, minus infinity plus infinity. From here I am just taking, for example, 1 and 10, right? Now I am just taking out all the elements, set of all x, such that x belongs to real number and x lies between 1 to 10. Now this is the set where it has all the real numbers from 1 to 10. All the, not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 alone. It will have all the real numbers from 1 to 10. Right? Now this is of course a subset of real numbers. Right? Now instead we can write this set in a more short way, more concise way, so that it is easy for us to write it. Right? So I can write it as like this: 1, 10 closed interval. This is called as an interval. If for real numbers alone, that too for if I take all the real numbers continuously in this way, I can write it in this way, which is called as an interval. Right? So this is called as an closed interval. Why? Because here 1 is also included, 10 is also included. So I'll use square bracket on both the sides. In case if I use like this, if my set is like this, where 1 is not included but 10 and 10 is also not included, for this I'll be using open interval 1, 10. What is the difference between this and this? Here 1 and 10 are included, all the numbers in between are also included. Closed, we call it as closed interval. Right? Here it is open interval. Here all the numbers between 1 and 10 are included. 1.01 will be there, 1.001 will be there, 9.999 will be there, but 1 and 10 will not be there in this particular interval. Right? So this is closed interval and this is open interval. Right? The next case is, let me put equal to here and don't put equal to here. This will be written like this: 1 is included but 10 is not included, and all the numbers in between are included. All the numbers in between are included. 1 is included but 10 is not included. Got it? Then if I write like this, if I remove equal to here and if I put equal to here, how will I write this in interval form? I'll write as 1, 10. Right? Here 1 is not included, but 10 is included, and all the numbers in between 1 and 10 are included. Right? So these are the 4 possible ways of writing an interval. Right? So this is called, we call it as an interval. When which subset can be written in interval form? Subset of real numbers, where if we take continuously, we can write in interval form. Okay? Right? But whereas if I take natural numbers, I cannot write in interval form. We have to write in the normal procedure how we used to write in set builder form. Right? So this is the concept of interval. Now we will get into the next topic now. And if you want to draw this in the number line, how will it represent it? We'll see that and we'll get into the next topic. Right, let me take, if you want to draw 1, 10 in interval, how will you draw it? We'll draw a real number line, 1, 10. So I'll just highlight like this. I'll highlight like this. 1 is also included, so put a circle and color it. Put a circle and color it. Okay, 1 and 10 both are included. This is 1, 10 closed interval. 1, 10 open interval. How will you draw on the number line? Same way, you have to draw a number line, minus infinity plus infinity. 1 and 10. Highlight it. Circle it, but don't color it. Don't color 1 and 10 because 1 and 10 are not here. We are coloring it because 1 and 10 are included. Here we are not coloring it. Why? Because 1 and 10 are not included. Now we'll see 1, comma 10 where 1 is included and 10 is not included. How will we draw on the number line? Minus infinity plus infinity, 1, 10, which is included? 1 is included, so color 1, 10 is not included, so circle it, don't color it, and in between elements are there, so highlight it. Okay, yes, right. Now then, 1 is not included, 10 is included. How will you draw the number line? Minus infinity plus infinity, 1, 10, and circle here, you must color 10, shade 10, and 1 must be left as a whole. Okay, because 1 is not included, 10 is included, and the numbers in between are included, so just highlight like this. Got it? So this is how we will represent intervals in the number line. Hope you got it. Now we'll get into the next topic. Right. So if I want to find the intervals for all the 4, let me take the intervals. What is the length of this interval and this interval? For all the 4 intervals, the length is the same. What is the length? Length is nothing but 10 minus 1 equal to 9 is the length. Okay. If I want to give it as a formula, if this is A, if I take this to be A and this to be B, yes, what is the formula? The formula is nothing but B minus A. B minus A is nothing but the length of the interval, whether it is closed interval or open interval or one side closed on left hand side, closed on right hand side, whatever it is, the length of the interval will not change. If you have any doubt in this concept, length of the interval concept, you can comment in the comment section below. I'll try to answer it in the next video. Right. Now coming to the next concept. So just will go with it. If I take an interval 2, 9, what is the interval? Length of the interval? 9 minus 2 equal to 7 is the length of the interval. Right. Now we'll get into the next topic. Right. The next topic we are going to see is, now you know what is a subset. Let me take a set A equal to A comma B comma C. Now what are the possible subsets you can have for this set? Let me take what can take. I can take A alone, I can take B alone. First of all, I can take a null set. Empty set is always a subset of all the sets. Empty set will always be a subset for all the sets, because everything starts with nothing, right? Everything starts with nothing, yes or no? So if, everything starts with an empty set, so empty set will be a subset for all the sets. So this is one of the possible subset. A alone is one of the possible subset. B alone, C alone, A and B alone, then B and C alone, A and C alone, all together A, B, C. All these things are possible subsets of this particular set A. Okay. Now how many elements are there in the how many possible subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. Now is it possible without listing like this? Can we tell directly, if I give a set, how many possible subsets for that set? Yes, we can do it. We have a formula for it. If a set has 5 elements, the possible subsets of this set is 2 power 5, right? If a set has 7 elements, the possible subsets is 2 power 7. That is, if you take a general formula, if n of C equal to, for example, m, right, then the number of possible subsets is 2 power m. Hope you got it. If the number of elements in this set is m, then the number of possible subsets is 2 power m. So accordingly, if you can just cross check with this, what we have done. So number of elements is what? 1, 2, 3. 2 power 3 is what? 2 power 3 is nothing but 8. So let me check it. 1, 2, 3, 4, 5, 6, 7, 8. So we got it right. Yes. So the number of possible sets, the formula is 2 power m. 2 power m. Now coming to the next concept, which is called as power set. Power set is nothing. Just now we saw it. These are all the possible subsets of A, right? These are all the possible subsets of A. Now, if I take all these as an element of some set, that is, if I take this to be a set, all these elements as a set, then that set is called the power set of this set. We write this P of A, power set of A. That is, the possible subsets of A If I write it as a set, write all those possible subsets as a set, then it is said to be power set of A. So let me give you one more example. If B equal to 1 comma 2, what is the power set of B? Power set of B is, what are the possible subsets? Null empty set, 1 alone, 2 alone, 1 and 2 alone. That's it. Now this set is the power set of B. So we can use the same formula what we have seen for number of possible subsets. Number of possible subsets for a set is 2 power m, right? Yes, same way. What is the number of elements in a power set? If n of A has 3 elements, if n of A has 3 elements, number of elements in P of A will be what? P of A is nothing but the possible subsets, right? So same formula, 2 cube. 2 cube equal to 8. 2 cube equal to 8. So same way, if n of B equal to how many? 1, 2, 2 elements are there. So what will be n of P of B? N of power set of B will be what? Equal to 2 power 2, which is nothing but 4. Yes? I hope it's clear for everyone, right? So the next concept that we are going, so power set, I hope it's clear. Now we'll get into the next topic. So the next definition is universal set. Universal set. Now this concept universal set is little bit, it may be confusing for some of you. Okay, let me get into the universal set now. Universal set is nothing but, if you are dealing with, for example, I am telling that A equal to A comma B comma C and B equal to B comma C comma F. I am just dealing in this particular problem, I am just dealing about what are the elements I have here, A, B, C or B, C, F, right? So here we are dealing with A, B, C and B, C, F. So what are the, on the whole we are dealing with just alphabet, English alphabets, right? So universal set, either I can just write A, B, C, D, E, F alone, because we don't have any alphabets after F, right? So I can stop with F itself, or I can take universal set to be, for universal set I'll use capital U. Okay, for this particular problem I can take either this to be my universal set, or all the English alphabets, all the set of all x, such that x is an alphabet in English. X is an alphabet in English language, right? So this universal set may vary from person to person, because we must take something that we are discussing in our problem. For example, if my set A is in set A I have some chocolates, and set B I have some other 3 chocolates, right? In set A, if I have Dairy Milk, Milky Bar and Kit Kat, and in set B if we have Oreo, Munch and Perk. Now here I am just dealing about, here what will be my universal set? Either I can take set of all chocolates, because I am just dealing with the chocolates, or I can just take set of all bakery items like that. Okay, that is what are the content we are dealing with. Accordingly we can take any universal set. I hope it's clear for everyone. If you have any doubts in this universal set concept, you can just comment in the comment section below. We will surely clear it in the next video, right? And in last class I asked you a question, that what is the difference between natural numbers, both are infinite, and but what is the difference between natural numbers and real numbers? What the difference is, this is also infinite, this is also infinite, but here we can count it, because the after 1 I know it is 2, after 2 it is 3, after 3 it is 4. I can count 1, 2, 3, 4, like that I can count it, right? Yes or no? But here we cannot count itself. It is infinite and we cannot count also, because for example, if I am starting from 1, for example, let me start from 1, I don't know the immediate next element. If I say, if you tell me that after this, if it is 1.01, I will tell that 1.001 will be in between these two. Okay, if you fix this to be the next element, I can tell that 1.0001 will be in between these two, right? So we cannot tell the next element itself. Fine, right? So here we can count it. It is countable. Here it is uncountable. We cannot count itself. But both are infinite. Here it is countable. Here it is uncountable. Right. So if you have any doubts in the problem, in the concept that we have discussed, you can comment in the comment section below. We'll try to answer it in the next video. We'll see some more concepts and definitions inshallah in the next class. Please like, share and subscribe with your friends. Thank you.